In this video, we are going to look on solar system protection devices. So you will understand that in solar system, there should be a protection in the system because the system should carry the fuse, the DC breaker, the DC surge, the AC surge, and also AC breaker, DC breaker, and all other protective devices. And we are going to list them right in this video. So maybe you might have seen a system whereby they install something like this, a box like this on the system, and you can see that this one is a breaker. This one is a breaker that we use to break the system in and out. To break the power supply and to switch on the power supply, maybe coming from the panel, then run it down to the system and to circulate power all around the system. And protection in this system is paramount. You can't do without putting these things in place. And we are going to make sure them in this video. And this protection devices have to do with, we have the fuse, then we have the DC surge, then we have the AC surge. We have the DC breaker. This is an example of a DC breaker. You can see it here. This is an example of a DC breaker. You can see it here. This is a DC breaker. Then we also have the AC breaker. Then we have the AVP, which is automatic voltage protector. Another thing we have is MCCB. Then we have other breakers in the system. So having this system, all these breakers in place tends to make the system to be protected against surge, lightning, or even over voltage or under voltage in the system. So these are protection devices that will help you to make sure everything works well. And in case something happens, these breakers are there to minimize any fault or anything that will happen and protect your system. So that in case you spend money to install your solar system, you can be able to enjoy it to the fullest. So we are going to look into this one after the other to see what are the uses and where are they going to fit in the installation, because there is a place that they connect the system within the solar system. From the DC surge, the AC surge, the DC breaker, AC breaker, the AVP, the MCCB, and any other protective devices you have ever found on the solar system. There are ways, or there is how they connect it. There is how they connect it to this system, and there is a place that will be put it there, maybe between the panel and the controller, or between the battery and other systems. So this is what we are going to do here in this video. So first thing first, let's understand the number one, which is the DC surge. The DC surge is a DC protective component device that is like this. And at the top here, you have the input, while at this other, at the end this side, you have something like an earth. So this is the device that will bring, this is the device that whenever thunder, lightning, or strike want to come into the system, this is the breaker that helps to absorb the extra charges that comes through the lightning or the thunder strike. So in this place, they are usually labeled. This is DC, this is plus. I usually label DC minus, and it will be DC plus. Remember, in DC system, we make use of plus and minus. So this is the first point that your solar panel will enter. Then you will now loop it to another breaker, which is called the DC breaker, which takes us to the next breaker protected device we are going to look into, which is the DC breaker. The DC breaker is a breaker that serves as isolation. Then we have this the switch button in this middle. So it is being divided into two. Here we have divided into two. We have the minus, here we have the plus, and here we have the minus. So again, here we have the plus, and again, here we have the minus. This is the DC breaker. And when you connect to your panel, you send your panel to this place and you loop it to this other one. So that when you connect panel to this place you will connect it to the earth bar. To the earth bar on the enclosure bus or the breaker bus. You run it to the earth link that will be on the bus. So this is what will be needed to connect your solar panel and to make sure it is well protected. Then another thing I'm going to look into is the what? The AC surge. Now, the AC surge is a AC surge device, and it's usually labeled live and neutral. Then we have it at this other end. We have it. This is the earth link. Then you run it to the earth. You connect it to the earth bar or earth link or the breaker box or a closure box. So these are the things that are needed. More also, we also have the AC breaker. Number 4, we have the AC breaker. The AC breaker is just unlike the DC breaker. You have it is to isolate the power, and also if anything should happen that is excess voltage or current that is more than the rating, because all these appliances you are seeing have their own rating. All these devices have their own rating, and you use them according to the voltage or current that you are voltage or current that is passing through the system. And in case if there is excess voltage or current passing through it, it can be able to trip it up and let your system be safe. So this place we have it. This is AC. This is AC breaker. AC breaker. We have it in live. Here live. Then we have it here neutral. Here is also neutral. So I will be drawing the whole schematic diagram on how we connect it from using the your cable coming from the solar panel down to the final step of the installation. So, but let's understand them and their symbol first before we go over to the connection aspect. Number 5, we have what? We have the AVP, which is automatic voltage protector, and it is like this. It's just like the AC breaker. We have it like this, and at the top here you will see where they write in. At the down you will see where they write out. Right? So we still have them. Is an AC protected device that has to deal with the life, and this one is neutral. So this is actually our AVP, automatic voltage protector. So we have other ones that are MCCB that we use to break between. Sometimes we can use it between the panel when it comes to the panel before pass to surge, or basically we installed it in the battery aspect of it. So these are the things that are needed in the installation part and to protect the solar system from getting damaged through lightning, surge, or the thunder strike, or the overvoltage or undervoltage situation. Overvoltage and undervoltage can actually damage your inverter, and you can take it for repair. That will cost you a whole lot of money and the stress, and as that fact, you might not see the solar system to use because you have took it for repair. And if it takes 2-3 days to repair, you'll be in blackout for those days. And to avoid this, we have to know how these things works, how to put them in place, how to set them, and they are important, and how they will help us to protect the system. So let's go over and see the connection of how we connect it right from solar panel down to any other things before you get your system perfectly installed. All right, so in this place, we are going to look on how the system is being connected in this place. So let me quickly analyze how this system are being connected in this place and how you can also connect your own. Now, remember, we have panels, we have the 4 components complete, but because of hybrid inverters, we remove charge controller and we are running our PV right inside the hybrid inverter, which have inbuilt MPPT charge controller. So in this place, this is our panel. This is our panel, right? So these are our panels. So our output connection of the panel is being fed into the DC surge. This is a surge breaker. So the panel cable enter the surge negative part, then the positive part enter the positive part. Then we loop it, we take a cable, we loop it from negative to the negative, right? This is the negative, this is the negative, right? Then again, this is the positive, This is the positive. So this is the positive and this is the negative. So when it comes here, after looping it from source to DC breaker, then we bring it down to our point where they told us this is PV, then this is PV minus, and this is PV plus. They will indicate it in the inverter. Then when you go there, once you see PV minus and plus, you know this is where your output of your DC breaker, that your panel power is coming into, because this breaker is tends to isolate this panel power supply and also engage it back to allow the current to flow to the inverter. So this is why this breaker is here. It's also sized regards to the voltage and current that is passing in from the solar panel. So in case if it is more than the rating and anything happen along the line, it can help to trip off and not to damage the inverter system. So the next thing we look is this is the DC bus or the DC combiner bus, because I separated it. So DC should be on its own and AC should be on its own. Then this is on this side. This one is our AC bus. So everything that is here is dealing with AC power supply. So this is our DC bus, this is our AC bus. Now let's come over to the AC bus, which is AC breaker enclosure bus or combiner bus. Now we see that when it's changeover here, the changeover you are seeing, this is our own personal changeover that we brought. There's an existing changeover that we have to bring in the input power source and come and connect it to this place. Then we'll bring a cable and we'll tap it from this place to come and feed the AC surge. This is AC surge. This is AVP. Now let me explain the use of the AVP. Use of AVP. The AVP full name is automatic voltage protector. This is one of the major protective devices that we use to regulate the power coming from the NEPA or the generator. Sometimes the generator might be going up and down, and even the frequency is changing, and it might cause damage to the system. Sometimes it might bring the voltage that the NEPA might bring will be up to high voltage, can be up to 250, 280, 300 and above, and it's not going to be good for our system to harm or destroy the inverter system. So sometimes it goes down to about 150 or 160 volts, which is not ideal for the inverter system. So we bring in the AVP and we set it up. I have a videos where I've explained. I have a video whereby I've explained and demonstrate and practicalize on AVP how to set over voltage and under voltage. That is high voltage and low voltage on the AVP, so that whenever NEPA bring light and the voltage is too high, the AVP will see that it's too high and it can't give output until it comes down to the level of the value that you set before it gives output. Then when it goes below your low voltage, your cutoff voltage on under low voltage, the AVP will have to cut it off, see till it sees the value that you set, the figure that you set for low voltage. Then once it passes it, it will now begin to give power output to the system. So that is basically the use of the AVP, and it's very, very important. Many people inverter have been damaged because of there was no protective device such like AVP in the system. So you can't negotiate or undersize or overlook AVP if you want your system to be protected and last long, especially AC in coming to the inverter system. So another thing we take, so we connect it, we loop it from surge to AVP. Ideally, we can say use this one as our AC breaker, then from breaker to come to AVP, so that in case we don't want the power supply coming from here to run down to the inverter system, we can off that breaker, switch it off, and that is it. Then, but yeah, if there is no AC surge, you can use AC surge. If there is no AC breaker, you can use AC surge and AC. If there is no breaker, you can use AC surge and AVP in terms of the breaker, and it will still work fine. Now we are done with AC in. Now we are talking about AC out. Remember, AC out is that power that we are looking from inverter system. AC out is what gives us the power what give us the power supply that will power our home appliances such as the bulb, the lights, the fan, and everything you can think of. That is the output that we need, the output source. Now, this is the output source. Remember, it is neutral and live. We connect it to the down part. Since it's coming from down, the breaker you are seeing, which is this breaker you are seeing, you can see it clearly. You can see it clearly. You can see this breaker you are seeing. This is the switch. We off it. We do what? We on it. We off it. We on it. So either of the two sides, that you use, it is still going to make power supply to flow and also break off the power supply. So you have to put in such a way that it is like this. Let the readings be up. Let the readings be up so that you can also know that yes, you didn't turn it upside down. When the reading is up, you can place it. You can see when you can place it, and it will be really on that aspect of seeing it on and off. Then, since the wire is coming down, we pass it from the under, we connect it down, then we bring a cable, we connect it from the up, and it's come and feed the down part of our changeover to give us output. The output of the changeover is somewhere here, live, neutral, and this output is being connected to the house or the DB. Let's say the output is being fed to the DB. So in other words, when this power supply comes here, automatically it comes down to this point, and APP will have to check if it is within the set voltage of over voltage or under voltage. It will pass out to come and give inverter. While inverter is charging, is also while inverter is powering and giving out output again, is also charging our battery. I've also explained, there's a video I've explained how inverter system works. So do well to go and watch all those videos to get more knowledge from the solar system. So in this video, this is the entire system where you are doing a small solar setup. You can actually use this design and this pattern to size or to install this kind of breaker for that your solar system in times of protection. Remember, this is the earthing part. The source, both DC source and AC source will be earth. This is the earthing. From this AC source, this is the earthing. There is a bus bar or earth link that will be on the enclosure bus, right? So you have to connect it, pick a cable, an earth cable, you connect it from this point to this to the earth link or the bar on the enclosure bus. Pick it from the AC source and do the same thing to this other side. So this is how the protective device are connected, and this is how they work. And they are not the system or devices that you should overlook. If not, you might ruin the solar system even on the short term. So do well and make sure to study this video over and over again. In case you are doing your next installation or you are planning to get your own solar system, tell the solar engineer that these things are needed and to be in place. Even if your budget is small or even if your budget is low, don't neglect this aspect of protection, because you might end up spending that money and you will not see enjoy the system if peradventure anything happens to the system and if these things are not in place. So thank you so much for watching to this very end of this video. I hope you have learned a lot from this video. So do well to subscribe, because the only way you can motivate us and encourage us to do more of this kind of videos and content to keep coming out and be teaching you is to subscribe to this channel, like this video, share to other people who are willing to learn freely. And if there's any video you want us to do, make sure you drop it on the comment section. I'll record it and drop it on this channel and for you to learn for free. If you want anything like installation or training, both online or physical, we are available to train you to a professional level. And don't forget to also call us for your installation, and don't forget to also consult us or for us to do a design for you. And we are always available to help you get a good system that is sustainable, reliable, and affordable. Is very important. These are the major key factors on why these are the major key factors of you to enjoy your solar system to the fullest. Thank you very much for watching to this very end of this video. I remain my humble self, Engineer Isaiah Omoyibo, the CEO of Multi Global Engineering Services. And today, I will see you in the next video, and God bless you.